Welcome to Automated Visual Software Analytics. This part is about version control systems. We will give an overview about principles of version control systems, look at an example of a version control system, and see what repositories typically store. Let's start with what is a version control system. Most of you are familiar with version control systems because they are fundamental systems used in almost every software development project. A version control system manages all changes applied over time to all kinds of system artifacts, such as source code, documents, models, websites, configuration files, and any other information representation, any other related representation of a system component. Version control systems represent a key type of software repository, a repository that stores information about the software system. Most important are version control systems for source code, for example, Subversion, Git, or any other system. Now, let's see what are the typical features of a version control system. The typical features are very similar across all different types of version control systems. Main features include a mechanism for checking out or cloning certain parts of the system, and vice versa, the same reverse functionality to check in modified artifacts of the system called checkout. There's also typically a functionality that allows to split the development status into different branches. And of course, there's always one master line in the across all different versions of the software system called trunk. Yeah, if modifications are applied and before maybe it's branched, then at certain points the software developer, the software management defines this should be a new release, or this is considered to be a new release, and a mechanism that supports this revision definition is called tagging. Once we have several branches, sometimes they coexist, they get merged once again into the trunk, and according to certain tags we define different versions. We see somehow the development history of our software system, and this recording of the history is done by the version control system. Applications of version control systems are manifold. Of course, they include the reconstruction of all changes. So if we look back, if we want to inspect former stages or former versions of our history, we can systematically and completely reconstruct all these changes. Such a history is called the commit history. There's also a key application in recording changes in terms of insertions, deletions, or modifications applied to artifacts. This is maybe the core functionality, the core application. To record all modifications of system artifacts, especially if you have a large team, this becomes more and more important that you have a systematic way of recording changes. And the recall of versions and the comparison of different versions is also a key functionality. Sometimes you want also identify who, namely the developer, who applied changes to a specific artifact and when happened this modification. There's also an application with respect to analyzing and comprehending the introduction of bugs or the bug fixing, the correlated bug fixing, and in general the evolution of software features that helps to support software maintenance tasks. So you see, version control systems have manifold applications, and they are very precise. They record everything that defines the change of a software system. For that reason, they are very relevant for software analytics because they know the history of the system. Yeah, let's see different types of version control systems. For example, a centralized one assumes that there is one centralized server that manages the repositories, the database, the version database, and different clients connect to this server. They check out files, for example, at different client sites, and sometimes they check in and call other operations of the version control system. So each developer directly pushes or pulls from the central repository, and as one feature, also weakness, that this central server, of course, is also the single point of failure. So it's a very sensitive element in an infrastructure, because this server is used possibly by many developers. So it's a very sensitive element in an infrastructure. Yeah, examples of centralized version control systems include CVS, SVN, Team Foundation Server, or Perforce. In contrast to the centralized version, there's also a kind of version control system that operates in a distributed way. That means that the clients fully mirror the complete repository. If any server fails, any of the client repositories can be copied back to restore it. So every clone is actually a full backup of all the data. Examples include the Git system, Bazaar, Mercurial, and BitKeeper. With respect to the features, they do not differ too much. The way they operate is different, but from a developer's perspective, and even from the perspective of software analytics, the differences are not too big. So basically, this is a question of how you set up the version control system in your environment and which type you prefer. But from a functionality point of view, it's very similar. Yeah, example. As an example, let's look at Git. Git is a distributed version control system, and data is stored as a stream of snapshots, not differentially. So these snapshots somehow simplify the internal operation of the system. Each commit makes a snapshot of all files in the current status. And of course, if a file has not changed, only a reference to the previous identical file is used. And to ensure integrity, it operates on checksums at the lowest system level. So this is a very common and popular system that is used for version control. Git defines three main data areas. It's the repository, and from the repository you check out files of the whole system into your working directory, and once you are sure that you would like to modify certain pieces, you put it in the staging area, and from that staging area you commit your change back to the repository, and these changes are then distributed across the whole network of operating clients. The Git directory is the storage for metadata and objects, whereas the working directory is a single checkout of one version of your project, and staging area denotes that space is a storage for information about what will go into the next commit. So it's oriented along the typical workflow in a software development process. Especially the staging area is a very key and characteristic element of this version control system. Now, what is actually stored in a version control system? And that's an important question, because in software analytics, we would like to mine these data, to examine this data. Across all different version control systems, we have very similar schemas for the repository data. Of course, in the repository, we store the versions, the different versions of the system artifacts. That means the files, the whole directories, the subdirectories that contain, for example, implementation files. The source code, maybe documents, and any other files that belongs to the system's implementation. Repositories also store different data, the difference data. That means they have a functionality that allows us to get back to recall different versions of an artifact. The difference data, of course, is important if we look back and we would like to see the differences, the modifications that have been applied in the past. The third category of data stored in version control systems and in repositories refers to metadata. Metadata about software changes, about applied software changes. So it's a list of changed files. For example, one commit, one big change, consists of modifications of several files. The date of commits, when. The author data, name, email, who made the change, and the description of the subject. Why was this commit necessary? Why did it happen? The three main questions, when, who, and why, represent somehow the basic metadata that is managed by a version control system, possibly over the whole lifetime of a system. Of course, we have some additional information, the successes and predecessors, forming a list of changes, and they can be represented even as a graph. So what we can see here is that the repository, apart from storing the actual modifications of artifacts, has and stores and manages valuable metadata that can be used for software analytics reasoning purposes. We can ask who did change a certain part, or what are who was involved in a certain modification. So we can ask questions related to the team, to the development process. This is why version control systems play an important role in software analytics. Yeah, how is this done? How can we actually take advantage of version control system data of the repository? We have to parse repository data. This is possible because these systems generally offer a very open application programming interface or a functional interface or command line based interface. So it's easy to implement parsing strategies. Typically repository and revision traversal allow us to gather information, for example, find a path through a commit graph, iterate over revisions and files, or for each revision we can analyze the author, the date, the message, the subject, and for each file we can also analyze and extract metric values in considering the different versions of a given implementation file. We can ask, how did a certain metric, for example, lines of code, change over time for this specific file? So parsing is a general technique that allows us in software analytics to access valuable information stored in the repository, stored in the version control system. Let's summarize about version control systems. These systems are ubiquitous tools to manage the development of large-scale, long-term, complex computer-based systems. This kind of software repositories represents not only the source code base, but also a primary source of information about the system's evolution and the developer activities over time. The direct use of a version control system includes the management of changes to the artifacts of the system, including recall and comparison of different versions, version management, documentation of changes. We could also say these are the traditional uses, the common uses of a revision control system or version control system. But apart from these traditional applications, revision control systems also have an indirect use for software analytics. They possess valuable information about the system's evolution in terms of applied changes, the branches, the trunks, as well as the individual developer activities. Therefore, mining techniques for software repositories allow software analytics to take advantage of that information. Mining techniques will be subject to another part of this course. And keep in mind that normally in many today's software development processes, the software repository, the version control system, is just applied for these base tasks, but still not used for mining the evolution and analyzing the history and the processes over a long time, over a long period of time. So this is a key point for software analytics, a key entry point. Yeah, this concludes this part. Let's see some terminology. Version control system, once again, manages changes applied over time to files such as source code and any other documents, models, websites, and any other related representation of system components. It can be based on a centralized database or distributed database. A commit is a conformed applied change to one or more system artifacts recorded by the version control system along with metadata. Yeah, as further reading, I can recommend this article recently appeared about on analyzing the topology of commit histories in decentralized version control systems. So it's about what can we find out if we look back on the commit history. And there's also another article, the pragmatic version control using Git from 2009. Yeah, finally some remarks. Regardless of the team size, even if you are a single developer, a version control system is an essential element in any software development process and project. They precisely store the history of the system, its evolution, in terms of committed changes and allow, therefore, for efficient management of development activities. So even for small groups, it's an essential building block in any development project. The virtual control or version control system data tends to be big software engineering data throughout the life cycle of a complex computer-based system, because if you look, for example, on over 10 years on any changes, this is big software engineering data. Software analytics processes and transforms data stored in version control systems to elicit information about software evolution, to get out that information, to examine that information, and also about change histories. That is, software analytics fundamentally creates added values out of version control systems. Software analytics also seamlessly integrates this kind of information with other system-related information, such as measures of software metrics. This way, if it's combined, the history of a software system together with reflections on software quality by measuring software metrics, it offers insights over the system evolution. Yeah, this is a key goal of software analytics, and for that reason, software analytics takes advantage of and uses version control system and the data, especially the metadata stored in these systems.